the programming question for a final exam, and let me draw it for you. We are simulating the situation of a self-driving car on a multi-lane highway, where we might start out right over here after entering the highway, and we wish to finish over here as fast as possible. Now, one solution could be just to stay on the right lane, but that's often suboptimal because often the right lane moves slower than left lanes. The way I'd like to specify this is by cutting the highway into segments and providing you or your software with the speeds of those segments. So for example, it could be 30 on the right lane, between 40 and 50 on the center lane, and let's go crazy, 100 miles on the left lane. So the road is given at any point up to 3 choices. It can go forward, or it can do a lane shift. So in the rightmost lane, there's only one possible lane shift. To the left, there's no right lane shift. But if you're in the center lane, you might have multiple options for lane shifts. Now, a path will look like a sequence of lane shifts and straight motions that eventually return to the final goal location. The cost of this path is the sum over one of the inverse speed limits. So it's 1 over 40 plus 1 over 40 plus 1 over 50 plus 1 over 50. And to make this a little bit more challenging, I also assume that there is a lane change cost. So every time you change lanes, you're going to add a small cost, say 1 over 100. And because there's 2 lane shifts over here, it'll be 2 over 100. So the total cost of this path over here will be the sum specified down here. So your task is to write a function called path. It takes as an input a map like this. The cost for lane shifts as a value, that's just for the lane shift cost. An initial and a goal location finds the optimal path. In this case, this might be shifting to here, over to the left lane, staying in the left lane, shifting to the center lane, and shifting to the right lane, and outputs the total cost of the optimal path. Important, you can only shift lanes one at a time. You can't do double lane shifts. And you always have to move to the right side. You can't go backwards or so. In fact, that wouldn't be optimal either. So you wouldn't want to go backwards. So let's dive into the code. In your code, you find a specification of how a road looks like. This is a road that has 80 in the left lane, 60 as a speed limit in the right lane. You find plenty user instruction, read those. And you find the parameters into the path function, a road, a lane change cost, an initial location, and a goal location. And there's plenty test code at the end. There's a function that lets you build random roads, so you can test as much as you want. There's our solution checker for certain test codes that you can use to test whether the solution is correct. And here's some test cases, like this one over here, where you see a specific road that's 3-laned. The number of lanes is somewhat variable. There's a certain cost. There's a certain initial position, end position. And for the test cases, we actually provide the true cost, so you can test whether your function calculates the right number. Here's a typical printout that we generated for debugging during a run. There's a certain road environment, certain cost, there's certain lane change cost. With the starting position over here, the optimal path will shift you gradually in 2 steps to the left lane. And at the final point over here, we'll shift slowly back to the right lane to reach your exit position. I think you shift back over here to here, and this is your final position in this example. So you have to build the planner. You can use whatever method you'd like. And you have to implement the path function, and the path function has to return in the end just one value, which is the cost value that the optimal path attains. And for the test cases we provide, you can check whether you're correct by looking at the true cost value that we're giving you.